Hello again, student. So in this one here, we continue to solve some problem regarding for the complex circuits. And here I listed the guidelines with the 3 R's or RE, reduce and reuse and recycle. So this 3 steps as a guideline to solve the problem such like that. So basically, aside from the reduce, basically we need to reduce the resistors to find the equivalent resistors. And once you find the equivalent resistors, second step, reuse. So we use the equivalent resistors to solve voltage or the current using the Kirchhoff law. Once you find this equivalent one, we're gonna reverse the equivalent resistors to find the voltage and current through every element in my set. So in this example here, we have 4 resistors, and our mission to fill out this table by finding the potential difference in every single resistance and the current through every resistance. So we try to apply those 3 steps in my list here. Okay, let's start to do it. The first one, the reduce. So basically, I want to reduce my my circuit or my resistors in a level that I can find something from it. So the first one here, as you see, this is the 2, 5, and 5. The 2 resistors, they are in series. So I can find what we call it R equivalent 1, which basically 5 ohms plus 5 ohms. Series connections will be 10 ohms. So this is the equivalent one. So from here, reduce this case. I will use the reduced perspective. So the circuit shown up here, I have that level. So I have the circuit, voltage source, and have R1, and I have here is the R4, and I have here is the R equivalent to 1 in my case. Here, my equivalent first reductions. This is the circuit that I have. Stuck with that case. So here is the R equivalent 1, which 5 ohms. And here is the R4. And here still I have R1. Okay. The second step here, I can more reduction. So I still able to make more reduction case in this particular level. So I can move for the second reductions. Just change the color to make the reductions obvious. So I can deal with those 2 resistors here. They are in parallel. So the second reductions, R4 parallel with the R equivalent to 1. So I end up with the level of the reductions. Here is my source. Here is the R1. And here what we call it this time here R equivalent to. So here our R equivalent to. R equivalent to. Where is the R equivalent to? It's basically R4 parallel with the R equivalent 1. Parallel with the my R equivalent 1. So I have 1 over R equivalent 2 equal 1 over 10. Oh, sorry, R equivalent 1 here, sorry, is the 10 ohms. I type it incorrectly. Ohm plus 1 over 10 ohms. So I end up with the R equivalent to equal 5 ohms. So now once you end up with this reduction, so I am able to find the next level. Here is the second one, what we gonna move to the reduce and reuse. Reuse step. So basically I need to find the I total in my circuit here. We call it I total. Where is the I total? The current go in this circuit. Here is the R1, which equal in this case 5 ohms, and I have R equivalent to, it is 5 ohms. So I have now my 2 voltage like that. Okay, so I need to find the I total. What I have to do, I need to apply the Kirchhoff voltage law in this loop. I need to write down the first one here is the plus 10 volt minus I total times R1. R1 is 5 ohms minus the same current goes to the R equivalent 2. So I total, they have the same current, times R2 is equal 5 ohms. That's the algebraic summations equal 0. So from here, I can find my I total. In this case, will be 10 volts, divided by 5 plus 5 will be 10 ohm. So here is the 10 volt divided by 10 ohms. I have 1 amps or ampere is my total current. So here is my total current. Keep in your mind, here is the I total. It's the same current, what we find it here. Here is the same thing, I total. Okay, that's the reuse. Now, the last step here from the our steps here, recycle right now. So now I am in the stage of recycle. I'm gonna reverse let's change the color in the color easy to observe. Let's we use the red, we use this one. I'm gonna use pink one. Recycle here, what we're gonna go, we're gonna go reverse. So from the circuit here, I go back to this one here. So here's the I totals. I total, I can call it this one here, I R4. And here's the current here, I equal 1. Just indication to the resistor's value. So I can go in my loop. Let's use this part here right now. I'm gonna use the Kirchhoff law in this loop here, as we did in the previous one here. Let's start to type it. Here is the 10 volt minus what I have, R1 times I total. So here is the I total times R1, it will be 5 ohms minus, in this particular branch, I have I R4 times R4, with R4 is 10. So here is the I, sorry for my pen still give me some crazy lines. Here is the I, what we call it equivalent 1 times what the value for the R4, R4 is 10. 10 ohms equals 0. So from this equations here, where is the here? 1 amps. So the only thing is missing from my equations is the I equivalent. So I can find I equivalent 1 in this part will be 10 volt minus, here is the 1 times 5 will be 5 volt divided by R ohms. So I end up with the 0.5 amps. So this is one is 0.5 amps. And if you're gonna use the same concept, I will use the outer loop and write the equations here in the outer loop. I will end up with the same one. And again, here is the accidentally type R4 here, guys. R4. Okay, here is the R4. So this is small loop. If I use the outer loop, I end up with the previous one. So the only thing it changed is since in the R4, it will be R equivalent. So here's the R4 and I equivalent 1 equal 0.5 as well. Okay. Now I'm gonna go a step further, go back from here to this one here. I have two resistors in series, so they have to have the same current. So from this case, I can find I R2 equal 0.5 amperes, and I R3 equal half amperes. Now I have the entire currents. For the I4 and I3, it could be 0.5. For the I1, it should be 1 amps. And in the R4, what I found here is the half. So what left is left just regarding for the delta V. So delta V1, Ohm's law, so it's gonna be R1 times I total, or I1. Where is the I1? It should be I equal I total. So here is the 5 ohms times 1 amps. So in this here, it should be 5 volt. That's the delta V1. Delta V2 in the resistors R2, the same thing will be R2 times I R4. I have R2, it is 10 ohms, times a half amps. I end up with the 5 volt as well. Okay, now delta V3 will be R3 times I R3. I have the R3, it's 5 amps, times I, which will be 0.5. And in that case, 2.5 volt. And delta V4, it will be R4 times, 1, 2, 3. So here, if you want to take it seriously, this one just 4. So that's an R4. And here is the 2. Where is the 2? R2. That's what I mean here. Okay, so it's gonna be I2. Just so make it sure it's clear, guys, for everybody. So here is the R4. And here is the R4. Okay, I'm talking about this one. So this one, to make it clear, starting for this one. Now delta V2, it's the R2 times I2. Times I2. Where is this one talking about this particular case? Okay, so that's what I meant by that. So it will be 5 ohm times a half amps will be 2.5 volt. So now I use the concept reduce, reuse, recycle to find all the current and voltage through all my elements in my set. I hope you find this example is clear. I may plan, so on Thursday I'm gonna solve another example similar to this. Thank you so much, guys, for listening.